Welcome back to Young Tutor. Today we'll be taking up the topic algebraic expressions. It's a very large topic, so we'll be taking only one half of it. That's the expressions. Next time we'll be taking up the identities part. So the total topic is algebraic expressions and identities, but we'll be taking up the topic algebraic expressions only for this time. So now let's start up with what is an expression. An expression is a group or a conjunction of both a variable and a constant. So what are variables and constants? Variable is nothing but a letter, an English alphabet that has been assigned a certain value, but this value can vary, therefore its name as a variable. But a constant is something that has a fixed value and the value never changes. Okay, so now that we know what are variables and constants, let's actually create an expression or just understand how to make one. For examples of constants, every single known number or every single number in the end is a constant and is considered a constant. A variable can be any English alphabet, so we can take A, B, C, but these are some very rarely used variables. Usually the most commonly used variables is X and Y. These are very oftenly used, but Z can also be a very oftenly used variable. So now let's create an expression. So to create an expression, we can just write, for example, x plus 3. Here you can see that there is a variable, and for any variable the constant is always 1. If there is no a constant that you can see, the constant will always remain to be 1. And it will be and there is also another constant here, but there is no variable that follows it. So now that we understood how can variables have an invisible constant, that is 1, but remember that invisible constants cannot come for any other number except 1, because 1 into 1 multiplied by any other number is the same number itself. Therefore we can automatically write 1 over there as a constant. Now let's see how can we add two algebraic expressions. But to see how to add, we need to first know like terms and unlike terms. So what are like terms? To tell two terms, a term is nothing but just one pair or one set, like for example 3x or 3xy, like that. But the expression I'm about to write, for example this, cannot be added and therefore is at the base form of it, and therefore we can tell that there are two terms in this whole expression, the first term being 3xy and the second term being 4x. So to call to divide a certain expression into terms, we can say it in such a way that like another way to call an expression, that is a group of terms all having some numerical operators that come in between. It can be called as an expression. Remember, an expression does not include an equal to sign, because if it contains an equal to sign, then it will be considered as an equation and not as an expression. Okay, so now let's understand what are like terms. Like terms in algebra are considered to be the terms which have the same variable and the variable's power. So remember that the variable and the variable's exponent must remain same between the two different terms, but the constant may change and there's no problem with the constant. The important part is the variable and its power. So this practically comes down to the base. Even though there is an x, the power is different and therefore we cannot add these two terms. But for we only need to use like terms and unlike terms in the case of addition and subtraction. But for multiplication, there's no requirement of using like terms, because we can just multiply and get the new variable into the same term. Now let's understand how to plot a certain expression on a point or on a number line. So let's draw this number line and call the starting point O. So this, it starts at O and goes on. So we have to plot a certain point. Let's take the expression of x plus 5. So if the expression is x plus 5, then to plot the point over here, first you have to go x units, which makes sense, because if this is if it starts at 0 or 0.0, that is O is equal to 0, then if we have to go x units forward and then add another 5 units to that to reach our point P, as we named it point P. To reach point P, we need to go x units from O and then go another 5 units from that x. So this is how to get to the base level of how to understand a certain expression. Of course, it can get way more complex, but this is a simple way to understand what are expressions. Now let's go over to how to add or subtract two expressions in a simple way. So let's take that we have to add the expression 7x square minus 4x plus 5 and the expression 9x minus 10. So you can see that there are two expressions that we've added with a plus sign, giving us another expression, a bigger expression. But all we are trying to do is simplify this big expression into a smaller one. So how can we do it? So first we need to understand what are the similarities between these, or what are the like terms in these two. So we know that 7x square is completely a separate term, that is, there is no, it's a completely unlike term between all the other terms. So we'll write this term first. Now that we know that we cannot use 7x square, that will be separately kept. And now let's group up the like terms. So we can group it up by writing minus 4x, and then we have a 9x over here, so we'll also add that. And then we have the constants, only constants without variables, they also will be grouped up at the very end. So now you can see that these both are like terms and therefore they can be added because there's a plus sign. Of course, we can bring the 4x this side and 9x this side, causing it to be 9x minus 4x. But in the end, the answer is the same. So this is equal to 7x square. And now let's simplify this, which is 5x positive 5x. And then we get negative 5. So this is the answer. If you check, these two are also like terms, so we can subtract them. This is one way to add these two expressions. Of course, you don't need to do it in this method. You can also do it in the method where you put this expression under this expression, which is easier as the numbers are already grouped with each other. Okay, so now that we've understood how to add two different algebraic expressions, let's go over to subtracting them. So let's take the example that they've given a question to you to subtract the following in such a way: 5x square minus 4y square plus 6y minus 3. So this is the first term they gave, and then they wrote from 7x square. Wait, I'll write this on the bottom for easier understanding. From 7x square minus 4xy plus 8y square plus 5x minus 3y. So this is an expression they gave you to subtract. It might look big, but it's very simple. First we need to do is take the second term given. So in this case, the second expression given. The second expression is of course of the expression. Yeah. The second expression after the from, that is after whatever is written after from, we have to take this expression. Now so we have to write this expression first. And then we should put minus of. So the bracket is very important. After the bracket we should write 5x square and then copy the same whatever first expression you had. Now remember that we've already learned how does multiplication on two different signs work in the integers video and the rational numbers video. So now that we know about this, we can use this to our advantage, because in this case we can see that brackets always mean multiplication in math. That is, if there's two brackets given in an expression and if there's a minus in front of the first bracket, then we have to always convert every single sign to the opposite sign in whatever is inside the brackets. That is, what we have to do is first write the same whole expression down. And then we have to convert the signs and remove the brackets. So here it's a minus, you should put a plus. If it's a plus, put a minus. And if it's a minus, again put a plus. So now you can see that this term has been simplified. It might look very long, but of course we can simplify this even more. To simplify this more, we can take minus 7x square, positive 7x square, and minus 5x square and group it. Instead of grouping, we can directly subtract it, because we know that 7 minus 5 is 2x. 2x square in this case. Now for there's no term with the variables 4xy, only 4xy, so we can put that down directly. There's another expression with a 4y square, a y square as the variable, so we can do 8y square plus 4y square, which gives 12y square. Then we can see that there is no other x term or a term with the x continuation, x variable, so we can bring that down directly. There is another y term, however, so we can easily add these two numbers to be 9y, and then we can bring the 3 directly, because we've already used these 3 just earlier in these 3 this and this question. Now that you can see, this very complicated string has been simplified into this very small but very understandable answer. So this is practically what algebraic expressions is, and the subtraction is. So now let's move over to multiplication of two different algebraic expressions. Okay, so now let's start up with the topic of multiplication. Multiplication of two different terms is quite difficult and quite confusing, because we cannot exactly tell what should come as the answer at times. So let's start up with multiplying some very simple methods of multiplication, some simple sums. So let's take that we're multiplying 4 into 3x. So in this case, what we are doing, you might think that the terms are unlike, but we don't need to worry about like or unlike terms in multiplication. They are not useful at all. Because so now let's see what to do. So first thing we're going to do is take all the variables in in the terms given, all the variables, and write them at the end. In this case there is only x, so we'll put x, and then we'll multiply all the coefficients, that is the constants given in these, to be exact. Then there's a numerical constant and a variable constant. The variable constant of 3x is x, and the numerical constant, coefficient, is 3. Remember this because it's a coefficient, as there's not exactly a constant given for these for a term. For this it might be called a constant, but this is a variable term as it contains a variable, and therefore the numerical coefficient of this term is 3. Okay, so now let's understand what to do. So we have to multiply all the numbers and all the constants given, and keep the variables aside, as we have already put the variables at the very end. So so let's just take, as it's 4 into 3, it will be 12. So in this case 4 into 3x is 12x. Remember this. And now let's move on to another example to understand a little bit larger term. Let's take let's take the example 10y into 14z plus 140 yz. So in this case we can see that this is still a solvable equation, as we have multiplication involved. So first thing I always like to do personally is try to put the multiplication in brackets whenever possible, as that's the easiest part you can take care of, and it's very easy to solve multiplication in the end. So we can 10y into 14z is 140yz is equal to 140yz, and as we are adding with 140yz, all we have to do is double this. But remember that even though the variables are same, in this case we have to not make the variables squared. We have to always leave the variables the same. So these two are equal to 280 yz. Remember that the variables again do not square themselves, they just take another copy of themselves and put it at the very end. So now that we've understood how to multiply one monomial, a monomial is nothing but a single term which does not have an addition to it with another numerical operator, which is subtraction or addition in this case. So these are all monomials. Let's see how to multiply with a binomial. So we'll start up with monomial with binomial. So for example, let's take the example of 3x into, so remember that we cannot use the multiplication sign in this case, we have to use the brackets. We have to take, let's take for example 7 plus 2y. So we have to solve this equation, as we can further expand it to make it simpler for us to understand. So we can write this whole equation or expression as 3x into 7. So what we have to do is first multiply these two and then multiply these two, and in the middle put the sign as that is given. So this will apply for even trinomials, that is the same thing with 3 terms instead of 2. So just add an extra term, and in the end we have to just put a third arrow mark practically and multiply 3 terms and put the given numerical operator in the middle. So there's not much more complication in this. All we have to write here is 21x, put the numerical operator, and then multiply these two, which will give us 6xy. So it's a very simple topic, but it's still quite difficult to solve. So this is what we have to do for a monomial into a monomial. Now let's take up a binomial into a binomial. So let's take two same binomials. Two completely different binomials. So let's take 3x plus 5 into 2y plus 10x. So now that we can see that there are two binomials and we cannot exactly multiply both of them like in a simple way, so let's do one simple thing. We have to break this binomial up and convert it into two different monomials. So how we can do that is write it as 3x into 2y plus 10x, and put this sign here, and then write 5 into 2y plus 10x. So you see that we've doubled this one in both the locations, but we've also written spread out this one into this method. Now we can see that we have gotten a monomial into a binomial in both the locations, which we've already learned how to solve. So let me quickly solve it. So this is the answer. You could have also solved it yourself. If you have, then check your answer with this one. 6xy plus 30x square plus 10y plus 50x. This is the answer. It's quite simple. It's not too hard. So you can also try it yourself later. Thank you for watching, everyone. If you liked the video, then please hit the subscribe button, and also if you really enjoyed, then press the like button. Thank you for watching. The channel name is Young Tutor, and the handle is at youngtutor30. Thank you for watching. Goodbye.